Hello viewers, this is Wagner Ronald taking you through today's tutorial on integration 1 and its applications. And today's lesson shall talk about solids of revolution. So we shall start with solid of revolution formed by rotating a lamina about the y-axis. So suppose the area bounded by the curve y equal to fx, the x-axis and the lines x equal to a and x equal to b is rotated about the x-axis through one revolution, like as shown here. I think I can say that this is the curve y equal to fx, this is the line x equal to a, and this is the line x equal to b, and this is the x-axis. So when I rotate this curve about the x-axis through one revolution, it will form a solid which is in that shape, as you can see. So it will form a solid in this shape. From here, go this side, form that shape, and also that. So in this lesson, you want to use calculus to find the volume of the solid generated. So consider an elementary strip of thickness, small change in x, and length y drawn parallel to the x-axis as shown. The result of rotating this elementary strip through one revolution about the x-axis is to produce an elementary disk of radius y and thickness small change in x as shown. So this is the previous curve we had, but now we have put an elementary strip of height y and thickness small change in x. Now when I rotate this through one revolution, it will form an elementary disk in this form, I think, of whereby this disk will now be of radius y and height delta small change in x, and I think I say that this disk forms a shape of a cylinder. Therefore, the volume of this disk will go from the volume of a cylinder. I think remember the volume of a cylinder is pi r squared h. So in this case, r is y and h is small change in x. So this is what we saw previously. The radius of that elementary disk is y and the height is small change in x. Therefore, volume is given by pi r squared h. In our case, r is y and h is small change in x. Therefore, the volume of the elementary disk will be is denoted by small change in v and is equal to pi y squared small change in x. And with this volume, you can use it to get the total volume of the given solid generated. And that given solid generated, the volume v will be equal to summation of the volumes of all those small elementary disks formed from x equal to a to x equal to b. So in this limit, the summation sign becomes an integral sign from a to b, where a is this becomes the lower limit, this becomes the upper limit, and this small change in x becomes dx. Therefore, we shall come up with our volume as integral of pi y squared with respect to x from a to b. So this is the formula which you shall be using to calculate the volume of the solid generated. So we shall start with problem 1. Find the volume of the solid generated by rotating about the x-axis the area bounded by the curve y equal to square root of x and the lines y equal to 0 and x equal to 2. So when x, we shall start with getting the intercept. So when x is equal to 0, y will be equal to 0. Therefore 0, 0 is an intercept, and our shape and the shape of the curve is in this form. Now we shall take an element, the volume generated when it is rotated about the x-axis. So this is the x-axis, you rotate this shape about the x-axis. So what we do, we put our element in this form so that we can rotate it about the x-axis. When we rotate about the x-axis, we shall come up with this for this elementary strip. And I think I realize that now y is our radius of the elementary disk formed, and small change in x is the height of the elementary disk formed. Therefore, the small volume of this elementary disk of one elementary disk is equal to pi y squared small change in x. I think we already saw that. But we know that y squared from this expression, if I square both sides, y squared will be equal to x. Therefore, where there is y squared, I'll replace it with x. Therefore, the volume of this elementary disk is pi x small change in x. Therefore, when you put in this means that the total volume will be equal to the integral of pi x dx. So pi is a constant, it goes out, x is here, which is there, and this small change in x becomes dx, as you can see it here. Now from 0 to 2, you'll have to look at the sketch. The area enclosed by the curve, the x-axis, and this line will be this area. Therefore, we integrate from 0 up to 2. That is why you see here limits 0 to 2. So that's where the limits are got from. You have to use the sketch. So when I integrate x, I'll come up with a half x squared. And when I put substitute the limits, start with the upper limit, put it here, you come up with 4 minus the lower limit, substitute there to get 0. So when I simplify, I'll come up with 2 pi cubic units as the volume of the solid generated. Now we shall go to problem 3. Problem 3 says, determine the volume generated when the area enclosed by the two curves y equal to x in brackets x plus 2 and y equal to x in brackets x minus 4 is rotated about the x-axis. So the first thing to do is to get the points of intersection, which will act as our limits. So at the point of intersection, the two curves have equal values of y, so we equate the two, and when I open brackets, I'll come up with that, and when I simplify, I'll come up with that, and when I factorize, I'll come up with that, and that means that 2x equal to 0, implying that x will be equal to 0, or x minus 1 is equal to 0, implying that x will be equal to 1. Now these will be our limits. The lower limit, the smaller one, becomes the lower limit, and the one which is greater becomes the upper limit. Now we shall sketch the curve. This is the curve for y equal to x in brackets x plus 2, and this is the curve for y equal to x in brackets x minus 4 minus x. I think we saw how the shapes of the curves appear under application of differentiation. Maybe to remind you, when the coefficient of x squared is positive, the curve will have a minimum value, and when the coefficient of x squared is negative, the curve will have a maximum value. So that is why they have those shapes. The points of intersection were x equal to 0 and x equal to 1, as you can see here, 0 and 1. Now the area enclosed by these two curves is this. From here you go up to here, then from here you go up to here. So this area is the area enclosed by the two curves, and it's the one which shall be rotated. Now when I rotate, what happens? This is what will happen. It will form a hollow cylinder. Why? Because from here to here is not required. The only one from here to here, which is this shaded part. So this is what we saw previously, and that the volume of the bigger elementary disk will be pi y2 squared small change in x minus the volume of the smaller elementary disk, which is pi y1 squared delta x. When I simplify, I come up with that. But I know that y2 is equal to 4x minus x squared, so I square it, minus y1, I know my y1 is equal to x squared plus 2x, I square it, and when I expand this, I'll come up with this bracket, to expand this, I'll come up with this bracket. Now next will be simplifying. When I simplify and collect like terms, I'll come up with pi in brackets 12x squared minus 12x cubed delta small change in x. Therefore, now that I've got the expression for the elementary disk, volume of the elementary disk, I can now go to the total volume generated by integrating. So I'll integrate the whole of this. I think I realize that pi is here and the whole of this is here. Then small change in x has become dx. But remember, we have to put the limits. So the limits are from 0 to 1, which were our points of intersection. Now when I integrate, I'll come up with this, and when I substitute my limits, I'll come up with that, and when I simplify, I'll come up with pi cubic units, and that will be the volume of the solid generated. So we shall now go to case 2, where rotation is done about a given horizontal line. So problem 1-4 says, find the volume of the solid generated when the area enclosed by the curve y equal to root x and the lines x equal to 0 and y equal to 2 is rotated about the line y equal to 2. So previously we have been dealing with the rotation about the x-axis. Now we are going to rotation about a given line, horizontal line. So the first thing to do is to get the intercept. So the intercept is 0, 0. After getting the intercept, we shall sketch the curve. Now this will be the curve y equal to root x, and this is the line y equal to 2, and this is the line x equal to 0. Now the area, the rotation is done about the line y equal to 2, but first of all the laminar enclosed will be from here to here, from here to here, and from here to here. So this is what will be rotated, and because rotation is done about the line y equal to 2, this will now act as our small change in x, and this will be the radius, as you can see here. Now this radius is the difference from 0 to this, it is y2, and from 0 to here it is y1. Therefore the difference between the two becomes our radius, which is y2 minus y1. So this is the elementary disk formed by rotation above the line y equal to 2. Therefore the volume of the elementary disk will be equal to pi y2 minus y1, which is the radius, squared multiplied by delta x, which is our height now. So but I know y2 is 2 and y1 is root x, so I'll substitute, and now that I'll expand. When I expand this, I'll come up with 4 minus 4 x to power half plus x. And now that I've got the elementary volume, I can now get the total volume by integration. So integration, we shall integrate the whole of this. I think I'll say pi is here, this is here, and this delta small change in x becomes dx. And when I integrate, we integrate from 0 to 4 because this is integrate from here up to here, which is 0 to 4. That's why the limits are there. Now when I integrate this, I'll come up with 4x minus 8 over 3x power 3 over 2 plus a half x squared. And when I substitute the limits, I'll come up with that. And when I simplify, I'll come up with 8 over 3 pi cubic units as the volume of the solid generated. So now we shall go to case 3, where rotation is about the y-axis. So problem 5 says, find the volume of the solid generated when the area enclosed by the curve y equal to root x and the lines y equal to 0 and x equal to 4 is rotated above the y-axis. So the first thing to do is to get the intercept, which will be 0, 0, and after that we shall sketch. Now this will be our sketch, and this is the curve y equal to root x, and this is the line y equal to 0, and this is the line x equal to 4. Now the laminar enclosed will be from here to here, from here to here, and from here to here. But remember, rotation is going to be about this line, rotation will be about the y-axis. Therefore, when I rotate this, I'll come up with this elementary disk, which is hollow. Why is it hollow? because from here tier is not required, that's why we cut it off from here tier. What we want is from here tier, which is from here tier. Therefore the volume will be got by first getting the bigger volume of the bigger elementary disk minus the volume of this smaller elementary disk which was cut off. So the volume of the bigger elementary disk is pi x2 squared delta y minus volume of the smaller elementary disk, which is pi x1 squared delta small change in y. And when I simplify, I think we'll see that pi is common and small change in y is common, so I'll remain with this. But I know x2 is equal to 4, therefore x2 squared will be 16. And x1 is y squared, therefore x1 squared will be equal to y to power 4. And now that I know the expression for volume of the elementary disk form, I can now get the total volume by integration. So pi is here, the whole of this is here, and delta y becomes dy. So when I integrate, I'll come up with this, and when I substitute the limits, I'll come up with that. And when I simplify, I'll come up with 128 pi over 5 cubic units as the volume of a solid generated. So we shall now go to problem 6, which says that find the volume of the solid generated by rotating about the y-axis the area bounded by the curve xy equal to 1 and the lines x equal to 0, y equal to 2 and y equal to 5. So we shall first get the intercepts, but when x equal to 0, I think I realize that y is undefined, and also when y is equal to 0, x is undefined. What does that mean? It means that x equal to 0 and y equal to 0 are in asymptotes. Therefore, the curve never touches these two lines. Next is to sketch. I think we realize that this curve does not touch this axis, and this curve also does not touch this axis. So this is the curve xy equal to 1, and we're also given the lines x equal to 0, y equal to 2, and y equal to 5. So x equal to 0 is this, y equal to 2 is this, and y equal to 5 is this. Now the laminar enclosed will be from here to here, and from here to here. Rotation is done about the y-axis, therefore the elementary strip will be in this form. This is the small change in y, and this is the x. Now when I rotate about the y-axis, the elementary disk formed will be in this shape, whereby x is our radius and small change in y is our height. Therefore the volume of that elementary disk will be pi x squared small change in y. And to get the total volume, I'll integrate from 2 to 5. 2 is here, 5 is here. Of this, which is pi x squared small change in y, becomes dy. But I know that x squared is equal to 1 over y squared. So when I integrate 1 over y squared, I'll come up with negative 1 over y. The limits are from 2 to 5. So when I substitute the limits, I'll come up with this. And when I simplify, I'll come up with 3 over 10 pi cubic units. And that will be the volume of the solid generated. So it's now your turn to try the following problems. So that has been our lesson for today. Thank you for watching, and please subscribe to my channel, Rowa e-learning platform. Thank you.